Welcome to This Explainer. Today, we're not just staring at lines of text. I want you to imagine JavaScript as a massive, glowing, futuristic metropolis. You see the shiny user interfaces, the reactive components, and the smooth animations on the surface, sure, but to truly master this language, we have to go underground. We're going to explore the hidden infrastructure, the power grids, and the cutting-edge architectural standards that actually make modern JavaScript run. Okay, let's dive into this. Here is our architect's blueprint for navigating the engine. 1. Foundations of the code. 2. The global execution context. 3. Mastering the event loop. 4. The modern JavaScript arsenal. And 5. Architecting real-world applications. Section 1. Foundations of the code. Laying the grid of the digital metropolis. Look, rushing through syntax is a guaranteed recipe for a fragile infrastructure later on. Everything complex in JavaScript eventually boils down to the absolute basics. It's a case-sensitive language, and it relies heavily on mutable arrays and objects to organize complex data structures. Arrays give us our zero-index lists, while objects give us unordered key-value pairs. Together, they form the literal data grid of every single app we build. And this brilliantly illustrates how JavaScript's power completely adapts to its environment. In a browser console or an HTML script tag, you are interacting with the window object inside a super strict security sandbox. You absolutely cannot just read a user's hard drive. But drop that exact same code into a terminal runner like Node.js, and boom, your global context shifts to the global object, granting you full operating system I/O access. The environment dictates the rules of the city. Section 2. The global execution context, descending into the power grid. So every time you run a script, JavaScript doesn't just blindly start executing line 1. No way. It creates a global execution context in a crucial two-part process. First up is the memory creation phase. The engine rapidly scans your source code and allocates memory for all your variables and functions. It's just mapping the territory. No code is running yet. Only after that's totally finished does the code execution phase begin, where the engine actually runs your code line by line and does the heavy lifting. This two-phase boot sequence perfectly explains hoisting. You've probably heard that JavaScript move your variables and functions to the top of the file, right? Well, actually, scratch that. That's a total myth. The code doesn't physically move anywhere. Because the memory creation phase happens first, JavaScript simply allocates the memory space proactively. So by the time execution starts, it just feels like they've been hoisted to the top. Now, how it allocates that memory depends entirely on your syntax. Good old legacy var declarations get allocated and automatically initialized as undefined, and we have all felt the pain of unpredictable undefined errors sneaking into legacy code. Modern let and const, on the other hand, are allocated but strictly remain uninitialized in what we call the temporal dead zone, or TDZ. Try to touch them before execution reaches their line, and the engine throws a hard error. It's a massive, massive safety upgrade for the grid. So, whenever your code actually calls a function, it spins up a function execution context. Think of this like a localized, dynamic mini power generator just for that specific function. It has its own memory phase and execution phase, and if it needs a variable it doesn't have, it uses the scope chain. It looks up to its parent and its parent's parent, all the way back up to the global level to find what it needs. Section 3. Mastering the event loop, the concurrency engine. Let this sink in for a second. JavaScript is single-threaded by nature. There's no paralleling, only concurrency powered by an event loop. It has one single call stack. It can literally only execute one command at a time. The event loop is the absolute saving grace here, preventing long-running operations, like fetching network data, from completely freezing up your browser screen. Inside this glowing concurrency engine, we've got a few key pieces of architecture. The heap for unstructured memory, the call stack, acting as a last-in, first-out tracker for active functions. Then we have host platform APIs. These are the background threads managed by your browser or Node.js. And finally, the two waiting rooms, the macro task queue for things like timers, and the micro task queue, which is a super high-priority VIP lane specifically for promises. So the crucial point is the strict priority difference between these two queues. Microtasks, like your resolved promises, are absolute VIPs. The engine is going to drain that entire microtask queue immediately the exact second the call stack is empty. Macro tasks, like set timeout, are much lower priority. The engine executes just one macro task per event loop iteration, and then pauses to check that microtask queue all over again. Let's see how this builds into an actual sequence. Step 1, synchronous code runs on the call stack. Step 2, the call stack clears completely out. Step 3, the event loop checks the microtask queue and immediately drains every pending promise. Only after that queue is totally empty, step 4, will it execute the very next macrotask timer. This is exactly why a resolved promise will almost always log to your console before a 0-millisecond set timeout triggers. It is all about architectural priority. Section 4, the modern JavaScript arsenal, emerging into the ES6 Plus skyline. Now that we've got the engine figured out, how do we write clean code that harnesses this power? Well, the ECMAScript standard keeps giving us amazing tools. Here is your essential modern toolkit. Template literals for super clean string interpolation. Destructuring to easily unpack objects and arrays. Spread and rest operators for expanding or collecting data. ES modules for clean architecture using imports and exports. Plus, massive lifesavers like optional chaining to prevent crashes on missing data and nullish coalescing for strict null checks. But the skyline keeps growing. Yes, 2024 brought us something really incredible: native set operations. Before, if you wanted the union or intersection of two mathematical sets, you were writing custom loops or pulling in heavy libraries. Now, it is baked right into the language runtime at maximum engine speed. ES 2024 also dropped non-mutating array methods, so we can reverse or sort arrays by generating a fresh copy, perfectly preserving our original data state. And looking right on the horizon to ES 2025, we get explicit resource management. By introducing the block-scoped using keyword, JavaScript can finally guarantee the automatic cleanup of database connections or file handles the exact second they go out of scope. It elegantly replaces those incredibly clunky try/finally blocks we used to rely on. It's just a huge, huge win for memory management and system stability. Section 5. Architecting real-world applications, the progressive project ladder. All this theory is great, but we really need to apply these under-the-hood mechanics to building actual apps. Mastering JavaScript architecture doesn't happen overnight. It is a staged, progressive ascent. A 12-week timeline is highly recommended here. You spend the first 4 weeks strictly on foundations, variables, loops, basic DOM stuff. Weeks 5 to 8, you transition into arrays, APIs, and the event loop. And weeks 9 to 12 are where you integrate modern ES modules, build tooling, and eventually jump into full frameworks like React. Now, what's really interesting about this slide is how these projects scale right alongside your understanding of the engine. In phase 1, you build a tip calculator. That's pure synchronous call stack execution and basic DOM manipulation. But by phase 2's weather app, you're forced to engage the microtask queue with promises, asynchronous fetch APIs, and JSON. And by phase 3, you're architecting a full single-page app, coordinating client-side routing, state modules, and local storage caching. You aren't just writing scripts anymore, you're engineering software. Which brings us to our final thought. We've explored the memory creation phase, the hidden priorities of the event loop, and the modern syntax powering today's web. So now that you understand the ghost in the machine, how will mastering these hidden mechanics actually change the way you architect your next JavaScript project? Will you respect the microtask queue? Will you build immutably? The blueprint is entirely in your hands. Thanks for joining me on this explainer, and keep building.